Hello, everyone, and welcome to today's webinar on an introduction to rural road design using RoadEng. For those of you who don't know me, I'm Erin. I'm one of the resident webinar hosts here at Softree, and with me today is Matthew Dickey, our training manager. So today we are really going to be focusing on a core workflow that helps you to understand how you can leverage RoadEng for corridor design. And I'm saying corridor design as opposed to road design because you will see in a few moments that it is applicable to all different types of corridors. But first, if you are new to the software, I just wanted to give you a quick 20-second introduction to what it is, what it does. So RoadEng is a geometric design software. It is highly interactive. As you can see here on the screen, a whole bunch of different windows. They all interact with each other, giving you your design in multiple views and updating near instantly in all of the windows when you make changes. RoadEng is built for rural infrastructure, meaning that we are really well suited to long corridors, greenfield projects, and other ones that are sort of in that space. The software itself is modular. So today you're going to see us play in two different modules. By having modules, it allows us to kind of segment the different workflow items and keep our toolbars and our menus as simple as possible. The software is also standalone, no CAD software required. And then the other kind of key note here as I give you a very quick introduction to the software, there's two different versions, or two different, I should say, installer versions. We've got a civil engineer and a forest engineer, and sometimes this is confusing even for folks who are clients. Civil engineer and forest engineer basically are the same software, they just have very different sort of standards and settings that they call. Pretty much the same software, they have all the same functionality, and you can change those defaults. The last little note, because we're including this here today, is there is a sort of an add-on, sort of RoadEng Plus, and that's our Softree Optimal tool, so we will leverage that today. Okay, that's my quick background if you're new to it. Let's get into the fun stuff. So today we've got a couple core learning objectives for the webinar. As I mentioned, we're really going to be focusing on that high-level workflow for a road using RoadEng, guide you through the key features and functions that you're going to need to use in order to complete that workflow. Through that workflow, sort of three major steps that we're hoping that you can, yes, pick up on as we go through this. The first of which is how to import topo data and how to build that TIN model. So an essential step required for pretty much anything you do in our software, you need a TIN. Next, we'll move into the location module, and I really hope that you can kind of get a sense of how to create horizontal and vertical alignments, adding curves and working with and editing them. And then our final learning objective for today's webinar is about how you can leverage some tools in the software to help you optimize your road design for both cost, so here we're talking about earthworks costs, as well as for environmental considerations. So that's kind of our plan on a page. These are our core learning objectives. Now let's get into the actual workflow stuff. And it is worth noting that this workflow today really applies to many different project types, whether you're working in the resource sector, in mining, in wind farms, in county roads, in local highways, or in something that's not even a road itself, rail, pipeline. The fundamentals and the foundational workflow that we're going to talk through today really underpins all of these different types of projects. So part one, we're going to go into the terrain module to start. Here, we're going to import and work with our topographic data. And in today's example, that's going to be some LiDAR data. We're also going to do an initial optimization, figuring out where should we put this road. And this is done at more of a landscape level using Path Explorer AI. The second half of the webinar is all about the location module. This is our specialized module for working with corridors. Here we'll create our 3D road design, we'll design our horizontal and vertical alignments, and we'll also use Softree Optimal in this step as well to help us with a detailed cost optimization. So that's the location module. Okay, and then it's worth mentioning as well today, again, I feel like I've said this like 4 times, but let's say it again. Today is an introduction. There's a lot more deeper functionality that exists within the software, but we're not going to talk about that. We're really talking about this core functionality that's a stepping stone to more complicated projects like those shown on the screen: culverts, intersections, site design, walls, working with multiple alignments. So how it's going to work, I'm going to introduce the step in the workflow, then I'm going to pass it to my colleague Matt, and he's going to jump in the software and actually show you how to do it. So step one is importing your topographic data and creating that TIN model. So the software works with a whole bunch of different types of topo data. Today, we're going to work with some LiDAR data, but basically we need any type of data that has elevations. And then we take that data with elevations and we create something called a TIN model. Now, a TIN model is a triangular irregular network. It's shown on the right side of the screen, and it's basically makes a surface model that we can then work with. So once we've got that surface, we can start to do site design, road design, and do that. And with that, let's get into the software. Let's take a look at how to create a TIN model after we've imported some LiDAR data.
All right, so yeah, I'm gonna start right from scratch here. So as Aaron introduced, we are going to start in the terrain module. So I'm gonna open up the terrain, but we'll click insert file, and I'm gonna grab my data. So here we're gonna start out by bringing in the LiDAR data. So in this case, I'm working with LAZ data, and I'm gonna bring in a bunch of tiles. So we'll click that. Now, when we bring in that LiDAR data, of course, the LAZ files can contain all the points that the scanner hit. We're only interested in the ground points. And for this, we're going to work in the same projection as the file. So we're going to hit OK. And it's going to take a moment while the software brings in those millions and millions of points. So here we're not dealing with a super small data set by any means. So it isn't instantaneous bringing in all that information. But we do work well with that large data sets that would cause problems in other platforms. So this particular example, I think we're going to end up with about 7 million points in our file. And yeah, there really won't be any performance issues, and I'm not running a supercomputer by any means to do this. It's just, again, one of those things that we're good at, working with these large data sets. Yeah, and while that's brought in, we can see it's drawing those points. I'm just going to hit escape on my keyboard to cancel the draw, and we'll click off to the side. So here I can see the LiDAR tiles. I can see down here I've got 6.9 something million points. And again, as Aaron introduced, in order to use this, our software is really focused on the earthwork side of things, where we want to consider the ground that's there. So we're going to click terrain modeling. We're going to click generate, and we are going to generate our TIN. Now, the other thing that we have in the same dialog is not mandatory, but it adds context, and that's creating contours at the same time. So I'm going to create my contours. I'll go 25 and 5 for my intervals. We'll hit OK. And the software is going to think as it builds out that triangular irregular network. The TIN itself is going to be built fairly quickly, and then the contours will take a little bit extra time. And we can see right now it's building the contours, and it won't be long before we have our surface and contours. So we have the surface and contours. Let's check the 3D view just to get some extra context for what that looks like. Looks good, looks like what I expected it to look like, but if I wanted to change that, we could maybe change it to match whatever our personal preferences are for how we visualize that. I'm just going to change the color to be white, and I'll hand it back to Aaron.
So that was our first step. We imported LiDAR data. Again, this could have been many other types of data, as long as it's got elevations, and we created our TIN. So the second step, which I'll be honest, is kind of an optional step, but we think it's quite important, which is adding additional spatial data. So this can be really useful for adding more context and more understanding within your project. So there's two different types of additional spatial data. I should say, two different categories of additional spatial data. There is imported data. This could be something like GPS points. This could be a shape file. This could be a whole bunch of different additional data that you're adding in to your model. So in today's example, we're going to import some GPS points, as well as we are going to import a background ortho photo that was collected separately as part of the project. There's also the second category of generated data. So the software can actually help you get a whole bunch of context for your project by generating things like streams and ponds. So here it's going to analyze the terrain and determine the likely spots where streams and ponds occur. You could also do watershed boundaries, determining where those are. So the software has a bunch of tools that can help you generate that additional spatial data. The other thing we could do here is we could leverage live maps to bring in a background ortho image through the software for your project. But in this case, we're going to go with an ortho photo that we've got. So I'm going to pass it back to Matt, and we're going to talk about adding that additional spatial data just to add more context to your project.
All right, so picking up where we left off, I've got my 3D view. I'm going to just tile these so I can see both at the same time. And I'm going to add in my ortho to start. So I'm going to right-click, plane options, backgrounds. Now I've got an image here. We'll add that in as a background terrain. And there we are. Now, as Aaron introduced to, if we wanted to, we could connect to a map tile service and bring in our own ortho imagery from that if we would have rathered. But yeah, we have something here already. The other data that we're going to, for example, is those GPS points. So for that, we'll click Insert File. I have my GPS points as a KML file. So this particular data set came from Avenza, but we're not limited to any one GPS format. I think KMLs and KMZs are one of the more common ones, but yeah, it could be anything from your CSVs from your RTKs to maybe a GPX with a conventional GPS. But yeah, we're going to bring that in. I'm going to do the transformation for us on import. We're going to do a couple things here to make it a little easier to see. So I'm going to change my symbol. I'm going to change my color. And I'm going to add some 3D symbols here. And I'm going to make them a little bigger so we can see them in the 3D view too. So we'll hit apply. And there we are. So there's our GPS data. Now, in terms of what do these points actually represent? And they were collected in Avenza, so there's some field notes taken there as well. We can turn some labels on here. So I'm going to just set my scale to be something that looks nice, and I'm going to click Labels. I go in and I'm going to make a user-defined label that shows my feature labels that came from that Avenza file. I'll go show the name. We'll hit OK. We'll hit OK. And there we are. So this is where I'd like to start my road that we're working on. And if we go off here, we want to end here. So we're going to do a connector road between those 2 points. Now, to get from those 2 points, from there to there, I'm going to probably want to consider some other information. And of course, we could bring in more spatial information from other sources. It could be shapes, DWGs, etc. But here I'd like to consider my streams. So I'm going to go terrain modeling, hydrology tools. I'm going to use our streams and ponds tool, and we're going to set our parameters as we wish. So here it's raster-based analysis, and my stream drainage area represents a minimum drainage area to contribute to a point before we start creating a stream downstream from that point. So we'll hit OK. And it's a very fast tool. So in a matter of seconds, we've got all those stream vectors for our consideration. And with that, I'll pass it back to Erin.
Perfect. So Matt's now showed us how to bring in our additional spatial data, and he also indicated in this project that we have a known start and endpoint, which brings us again to another optional step in the process, but a really useful one. So in the next step, Matt is going to leverage Path Explorer. Now, Path Explorer is a add-on tool, part of that Software Optimal item, and I should mention it's also not included in your trial. So if you are a trial user, you're checking out this video or you're here live in the webinar, this part's not available in the trial. It's a little bit too powerful. So what it's going to do in this next step, it's going to optimize the location for the roads. It's going to analyze and explore literally tens of millions of possible locations to find the lowest cost constructible candidate solutions. Now, these solutions that Path Explorer is going to generate are going to make sure it goes from our start point A to our end point B, but it's going to consider things like minimum and maximum grade, your minimum horizontal curvature, and allow us to consider other constraints like the ones that Matt just brought in. So if there's an area of geotechnical concern, if you'd like to minimize crossings or perhaps even stay away from certain stream areas, you're able to leverage the hydrology tools and the features we just created in order to include those in the path exploration. So this is step 3. We're going to go now take a look at getting that sort of initial landscape level alignment that we can then leverage for detailed road design. So with that, we're going back to Matt and for our final step in the terrain module.
Cool. All right, so we've got our project with a surface. We've got extra information that we want to see and consider as we're deciding where to go with things. And of course, we could go with that conventional approach of either clicking around and deciding where we put the road, or we could put boots on the ground and spend a bunch of time walking around the hillside to try and get a rough idea of where we'd like to put it before we refine it. But Path Explorer is going to make our lives a whole lot easier, actually. So here I'm going to create a new feature, and I'm going to just give it a name. I'm going to set the start point down here, and I'm going to set the endpoint up here. So we have a feature that we're going to run Path Explorer on. Next, I'm going to go to my optimization tab. And again, as Erin said, that this isn't available for trial users. It can do a ton of really heavy lifting very quickly. So yeah, too powerful. And we'll put in our design parameters. So this particular example, I want to have a minimum curve radius of 50. I'm going to set my max grades to be 12. And if we just ran this as is, the software would still try to find the cheapest path from point A up here to point B down here. And when doing that, it would consider our earthworks cost. So we've got our default costs defined down here. And we can change these to match whatever we'd like. For this one, though, I would like to also consider those streams. So of course, if we're crossing a stream, we're probably going to need some kind of pipe or structure in there. And I'm going to add those in as construction zones. So I'm going to make those streams more expensive. So our construction zones could be no-go features where they're absolute do not go there. So it could be a no-go polygon if there is a, say, an arc site that we didn't want to infringe on. It could be a no-go polyline if we had a right-of-way limit that we didn't want to go across. It could be polygons where maybe we have shallow bedrock that's going to be more expensive, where we wanted to change the excavation rate for that material. So the dollars per cubic meter rate. But for streams, we're going to go polylines, and we're going to add a crossing cost for them. So we're going to select those layers here. We're going to say each one of those, and they're just minor crossings in this case. So I'm just going to go $3,500. We'll hit OK. We'll hit OK. And we are largely set up. Now this next thing that I'm going to click is something that you might not need on every project, but for this one, I want my road to start off being pointed in a manner that supports trucks traveling in this direction rather than going the other way. So I'm going to control my approach direction. I'm going to come in here and I'm going to say at the start, I want the road to be pointed going that direction. And then at the end, same but opposite, I want to tie in with that existing road. So it's pointed towards its origin. We'll hit OK. And it's going to solve a very large problem here in a very short amount of time for what it's considering. So with this, I suspect it's probably going to take maybe 30 seconds. But the exploring feasible paths is going to say, well, I've told it to find 5 paths. So it's already found 5 paths, but it's not converged on the cheapest solution yet. So once it does, it's going to say, well, that right there, unlikely to improve further. And we'll hit cancel. So it's unlikely to improve further. There's no need to keep running it. And we can see we have several options. Now, at this stage of things, we could go through and we could say, well, I don't like my road here just based off of a visual assessment. But if there is no clear best option out of the options given, we could right-click, select features by name, and we can see the feature names, and we can see the number afterwards. So based off the parameters we've given it, the costs that we're dealing with, this one's our cheapest. So we've got our Path Explorer feature, and $247 is the cost based off those metrics. So we can highlight and we can see which one probably makes the most sense to start with. Yeah, and if there's reasons you want more options, it's again just a parameter in here that you can set, but I went with 5. So with that, I am done in terrain for this road design project. I'm going to hit File, Save As. I'm going to save this as my topo file. So I'll hit Save. With that, I'll hand it back to Erin.
Excellent. So we have just finished off in the terrain module. We've saved our tin, which is our surface. We've come up with an initial alignment option, a sort of landscape level optimization. And now we're ready to go in and do more detailed corridor design. So location module is our module for corridors and alignments, and it has some special features, as you're going to see in the next few steps, that allow us to really easily design and work with them. So in step 4, we're kind of just going to get it set up. So there's sort of 3 elements here that we're going to address. The first is going and making a new location design project that references that 3D model of our topo that we just created. From there, we're going to potentially look to set up our screen layout, so making sure the windows are displayed in a way that we would like. And I should say that all of the windows inside both of that terrain module that we were just in and location are movable and configurable. And the way that they look and appear, we can actually save them in configurations called screen layouts. So here we're going to set up our screen layout, and then we're going to set up our typical cross section. So if you are less familiar with RoadEng, cross sections for us are the same as something like a subassembly. So we'll show you how to set up our typical cross section, and then we're ready to move into the alignment side of things. So with that, we're going back to Matt, and we're going to get in and create a new location design.
All right, so taking that screen back, I'm going to minimize terrain and open up location. So we've got location open. We're going to click new file, and we're going to reference that topo that we've just created. There we are. So I'll hit OK. And here we're going to choose our initial alignment. Let's since we had that Path Explorer feature we'd like to keep selected when we save terrain, it's defaulting to that. But if we didn't have Path Explorer and we wanted to manually click in where our alignment goes in location, we totally could. We could just start with a single point at the center of terrain or at a current point. But yeah, we have Path Explorer. It's going to be way faster than doing it manually and give way better results. So we're going to run with that. And here I can see my screen layout. Now with this one, my screen layout reflects the defaults that I've previously set up. So if I wanted to move this around and have maybe my cross section take up a little bit more space, I could move these windows around, get them however I'd like, and I could go View, Save, and if I save over my normal.dlt in this default directory, it's going to control what appears the next time I open the software. So it's not something that you need to do every time. It's just get something set up that meets your needs and that you intuitive to look at, and you're set. And you don't have to save over that normal .dlt. You could customize it to show a different configuration, and you can toggle between it just by clicking the drop down and switching over to that. Now I'm happy with the way mine looks, so I'm going to run with that. I'm going to add in that we have had in our background of terrain. So I'm going to do that here. And then, of course, our cross-section geometry. So our cross-section geometry is going to be an important part of the design. It's going to control how we interact with surrounding terrain. It's going to control volumes, all sorts of good, important things. So our cross-section templates are assigned by station range. So in the assigned by range parameter, and I have my default set from ... to ... which is start to end. Now we could have specific templates assigned for specific ranges if we wanted. So maybe I had my bridge template assigned for from station 100 to 110. So we can do that in here. What options we have available in this list though are controlled by what we have in the template editor. So here we can build out this library to capture all these different configurations for what we'd like to consider. Now, at the template level, we can control some global parameters. So I'm going to change my crown to be 4% rather than 2%. And we can expand this out and we have template components within it. So this, if I want to change, right now I've got my road width set at 2.5 meters either side of center line. Well, maybe I want a 6 meter road instead of a 5 meter road. We can just highlight that parameter, change the value, and we can see how it updates as we make those changes. So I'm going to go 3 on that side, and I can make the same change on the other side, or I can just delete the other side, copy, paste as right. So when you install the software, you're going to have 3 templates in the library, but if you had a need for other things, you could go onto the eLibrary and it has a vast collection of different components that you can piece together, and they behave just the same. So basically a fillable form controlling your geometry, and you can preview it before you apply it. So things like walls, barriers, etc., all live on the eLibrary. So I'm happy with the changes we made here. I'll hit OK. And since that was our default, we can see our road got a little wider. And with that, I'll pass it back to Erin.
Perfect. So next step, now that we've kind of got our location module set up with our typical cross-section, we are going to now start to go into alignment editing, starting with the horizontal. So because we were working with a Path Explorer feature it's come in to location kind of like the image here on the left. It's come in as a polyline. Now, this tool that we're going to first use can apply for any type of preliminary alignment. Perhaps you've created a preliminary alignment in another software, you've got a GPS track, a P-line. Leveraging this first tool called Polyline to Alignment can help us really quickly convert that polyline into a proper alignment that has curves applied. So we're going to start there. From that, we'll do a little demonstration of how you can manually edit your alignment. So again, we leverage these optimizations and these efficiency tools, but it's always an option to do manual editing. So we'll show you how to manually edit it, and we'll also show you a little bit about how to add and work with horizontal curves. So in our fifth step in our process, now that we're all set up in location, we've got our tin built that it's being referenced, we're now going to go into alignment editing, starting with the horizontal.
Alrighty, so as promised, we have basically a polyline. So we don't have proper curves. We have curves approximated with tangents and vertices. And rather than having to trace that out and add in our own curve definitions, we can streamline the process by running this polyline to alignment tool. So here I'm going to say, well, our minimum radius is still 50 meters. I'm going to add a little bit of leeway for it to deviate from that preliminary alignment. So smooth out things that are kind of insignificant for deviations. We'll hit over, and it's going to try to reduce the number of curves and IPs while maintaining that minimum offset. So again, we're going to let the software think for a bit, save us a bunch of time rather than clicking it through by hand or tracing that preliminary alignment by hand. And shouldn't take long here before it's found what we want to run with. And there we are. So we'll hit OK. So we can see instead of having a bunch of vertices, we now just have curves and tangents. So with this, I am happy with how this has ended up. If it were me, I wouldn't mess around with my alignment on this one. But of course, sometimes there's things that, oh, I didn't account for this and I want to move something. Or maybe it's you don't have the optimization tools and you want to design manually. Well, then moving things around is important. So if I want to move, say, that curve, I can right click here, edit IPs. I can pull it around and put it where I'd like. So if I want to go there, great. I anchor it down. If I want to change my curve specs, I can do that too. So I'm going to say I want a 600 meter radius curve. I can hit apply and we're set. Now, of course, again, I liked where it was, so I'm going to just hit undo a couple times. So I go back to the horizontal alignment that was calculated rather than something that I've manually messed around with. Yeah, so we've got our horizontal with our curves going from point A to point B in a matter of seconds. And I'll pass it back to Erin.
Excellent. So one of the things that's worth noting, when we leveraged that polyline to alignment tool, we actually removed our vertical alignment. So if you saw it, Matt's alignment in the vertical profile window was actually just following the ground. So in this next step, we're going to create our vertical alignment. So creating a vertical alignment is really similar to creating a horizontal alignment. We've got a tool that can help us do it through optimization, but you also have the ability to create your alignment with your mouse. This is sort of that add edit IP tool, clicking in your different IPs, and then you can add curves to it. And I just wanted to quickly step through sort of what that process looks like. So right now, if I can get this working here. There we go. Right now, the alignment that Matt's got in his, because we used polyline to alignment, it removed the profile and we're just following the ground. So to start, we can go and do that sort of manual process, designing a vertical. Then we can leverage optimization to basically move that profile in order to minimize the cuts and the fills. So yes, you can create your profile by yourself, or you can use a tool. And really just to highlight what that tool is doing is it's taking all those little cuts and fills and looking to minimize them, looking to minimize the excavation and embankment, as well as the transportation costs to move material as it solves the complicated problem of, where does the material come from to actually build this road? So all those small changes add up. And that's really what the major benefit of vertical optimization is, the cost reduction in earthworks through that process of adding up all the little changes and improvements in the alignment. From there, I'm going to go back into the software. We're going to talk about creating vertical alignments. Matt's going to show you all these fun things, including what vertical optimization can do after he designs it manually. With that, Matt, coming back your way.
So we've got our project, same place it was when we left off. If we want to tackle our vertical, we could do it by hand. So, and this does transfer back and forth to the horizontal. If I were to have started the horizontal without an alignment, I could basically do the same thing. But vertical, I'm going to work in my profile window. I'm going to click Add Edit, and I can go through here, and we can, click along and design our road. Now here, I'm just going to make it a little easier for folks to see what I have on the go here for grades. So I'm at 16%. We can pull that up. Now I'd like to keep it below 12. We'll pull that down. We can see our mass haul is, being updated in real time as we do those changes. And we can continue along, and we can see how those changes are interacting in all the various views. Now, if we decide we want to add a curve at, say, that IP, we have our horizontal curves panel that we introduced before. I've got my vertical curves panel here, and we can add in our curve specs here. So I'll add in a K value of 5. Now, this isn't a trivial length of road, so I am not going to do it all the way to the end because it's going to take time. Even if I did it all the way to the end and did the best job I could, it's not going to give me as good results as if I optimize it. So for this one, I'm going to switch over to optimizing my vertical. And there's some commonality between kind of how Path Explorer works and how the vertical optimizer works. So at the heart of it, we're considering earthworks costs. Now, this being an introduction, we're just assuming one ground type, so material type along the length of our road. And my default is set to have a cost of $12 a cubic meter and embankment cost of $4 a cubic meter. We've got our haul costs, so accounting for that lateral or longitudinal movement of material is absorbed in here. And with that, we can tell the software, we'll take those costs that we have applied. We want to sample along the length of our road. We want it to adhere to our design parameters. So I'm going to put in those design parameters here. I'm going to add control points. So here, control points are in the vertical if I want to be at this elevation at this point. So 2 points that I'd like that here. What's a connector road? I want to be right on the ground at the start of my road and right on the ground at the end of my road. So we tie in with that existing infrastructure. So we'll add those control points. And I'm going to click process. And here we can make some adjustments. So smart curves is going to allow us to remove curves that are insignificant, that maybe not be the absolute cheapest solution, but they are insignificant in terms of cost. And by removing them, we make for a simpler alignment. So the bigger the number you go with here, the simpler the geometry of the road will be, but it'll come at an offset of some costs, usually a trivial amount. So we'll hit process, the software is going to think for a bit as it samples along our alignment and then solves for where our vertical should be. Again, solving a very large problem in a matter of seconds. So, yeah, and so right now it's keeping track of how many sections we've sampled, and the actual optimization once we transition to that part is going to go fairly quickly here. So the optimization itself is done now. It's just calculating what that geometry will actually look like. And there we are. So I'm going to zoom out and we can see our curves along our alignment. We're adhering to all our design constraints. And with that, I'll hand it back to Erin again.
Awesome. So we've just gone through the process of creating our horizontal and vertical alignments. And now we're going to move into adding some additional sort of considerations to the project. And one of those is relating to drainage structures. So in the next step, step 7, we are going to explore how to add cross drains and pipes to this project. And that's done through the culvert editor panel. And so for this, really quick introduction, we're going to go back to Matt and take a look at culverts.
Excellent. So once again, picking up where we left off. If we decide, well, I would like to have a pipe here, we totally can. I'll just set my current point wherever I want it. So I've added my cursor there. We're going to go to our culverts panel and we are going to click add. So we'll add in that pipe. We can see a pipe appear in our cross section and we can highlight it. If we wanted to maybe change our skew, we can adjust that skew really quickly. So this is just controlling the orientation of the pipe. So we can see we've made those changes. We can see what we're dealing with here, and we could step through and we could add those culverts in at other locations where we think we would benefit from them. So let's do another pipe here. Now here, I can see the slope of my pipe isn't what I'd actually like, so I'm going to just change that slope, and there we are. So really easy to make adjustments. If we wanted to say change the culvert diameter, we could change the structure type. We could add a sump at our inlet if we wanted to with template overrides here. But yeah, that's the gist of it.
Okay, almost done. It looks like we're going to go a couple minutes over, so hang tight with us, everyone. This is step number 8 out of a total of 9. So in this step, we're going to now go and look at some of the different tools inside the software to help you review your alignment, as well as some reporting options that you have for, say, getting volumes, perhaps getting information about the culvert structures that you've included in the project. So we're going to take a look at the mass haul as well as how to work with data tables. With that, Matt, coming back your way again.
Now I'm going to back up, and usually we cover this right after the optimization, but I'm going to zoom out here, and this little graph that we have here is our mass haul diagram. So at a glance, the mass haul diagram is a great tool to get a feel for your project's balance. So we can see over the 2.4 kilometers of road that we are balancing, and our cuts and fills. So the highs and lows in our graph here are not super large. So our largest cut is, we've got a fill of say 1,000 cubic meters, and then we generate the cut material for it right there. And we've got some very short material movements for that as well. So I am happy looking at that mass haul as kind of a graphical indication of my volume surplus and deficits. Now, volume surplus and deficits are not necessarily the same thing as total cuts and fills. We could have some lateral movement in there that we wouldn't be seeing in the mass haul diagram. So if we want to get a tabular breakdown of that, we can go to a data table. Now this data table Again, it gets saved with your screen layout, so mine's set up the way I like it. But we can easily configure these to show whatever we like. And on this particular project, I have extra information that I don't want to see, so we can remove those columns. If we want to control how frequently we see those rows, we can do that in our point types. There we are. And if we scroll down to the bottom here, we can see we're cutting 5,200 cubic meters, filling 5,200 cubic meters, and we've got our aggregate fill, so that wearing course on top is accounting for 2,400 cubes. You aren't limited to just one data table in a project, so if we want to, say, add another data table, we can click that. This one's empty, so I'm going to right-click Data Options. And if I want to see a breakdown of all my culverts on this project, well, I can just say I'm interested in just my culvert points. So just this class of report points. And I want to see my station that those culverts appear at. And I want to see, we want to see the culvert diameter and length. We can quickly set that up and we can get that, again, tabular breakdown for other things aside from just our volumes. And with that, I'll pass it back to Erin.
Okay, last switch we've got, final step in the process, which is output. And really a design such as the one that Matt's just done is nothing if we have not been able to communicate it properly to those building the road. So here we're going to look at a couple different options for output. First is one of our most powerful output options. It's called multiplot. So that's kind of our own proprietary name. It kind of acts like a screen layout. It allows us to create output sheets in a really easy to set up, easy to save, share, and reuse configuration. From there, we'll take a look at drive-through mode. If you were paying attention at the beginning of the PowerPoint presentation, I did have it included in that little video on the location module slide. So drive-through mode is just a fun way to visually check your road, kind of puts you in the driver's seat and puts you on the roads you've designed yourself. And then the final option we'll take a look at for output is really how you can share your road design to other software platforms, whether that's taking it out to ArcGIS, whether you're going to another civil design software through, say, LandXML or DWG. We'll talk a little bit about how you can save as, because that's our export option, save as your project as a different format. So with that, I'm going to pass it over to Matt. I also, quick disclaimer, I think we're going to skip the questions in today's webinar, at least addressing them live. But we'd love to answer all of your questions, including all those great ones I see in the question section so far, afterwards directly with the question askers through email. So if you have a question, great, reminder, type it in that question section. We will tackle them after. I think today is all about keeping it simple and focusing on this introductory workflow. So with that, Matt, last step coming your way.
If we are happy with what we've designed and we want to put that design to paper or to PDF or to some form of digital output, well, we certainly can. So I'm going to start with the to paper or PDF side of things, and we'll go multiplot. And for this, we could build out our documentation entirely from scratch if we wanted to. So we could add in those various sub-views and build the out piece by piece. Now, we could also skip doing all that kind of foundational work, and we could cheat. We could go onto the Access Web Library, and we could, say, grab a plan over profile to use as a starting point. But we could, once we've had our first project, we could save a collection of chapters. So our document is organized by pages inside of chapters, inside of a workbook, and we could bring in an entire pre-formatted workbook. So I'm just going to click Open Book Layout. So I've got one already set up that I like to use that has my title page. I've got my plan over profile with various tables and whatnot to summarize my project. I've got that plan over profile chapter. I've got my cross-section chapter, and it just so happens, since this is set up the way I'd like it, there's very little that I'd like to change. So maybe we're changing our client logo or something like that, but yeah, the framework of what we're dealing with is the way I like it. So we could hit print and away we go. Now, if we would rather this document be a georeferenced document that we can take to the field for either construction review or maybe design review, we can hit File, Save As, and we can export that out as a Venza file. So then the plan, can see all these other views in the document, and we can also use it to take notes and have those notes appear right on the, well, a KML attached to our design. Yeah, so I guess getting that multi-plot set up is very painless. If we would rather it in a digital format for construction, maybe construction staking, File, Save As, and we can change the export extension to, well, any number of industry standard formats. So land XML being an awesome one for cross-platform sharing or construction staking or machine controls. Shape, great to go back and forth with the GIS folks, and other formats, DWG, DGN, DXF are all easily written. Yeah, and then the last one that I almost forgot to mention and was on our hit list here, if we would rather just, well, have a drive of what we have planned, we can right click, drive through, and away we go. And we can get a feel for what that's going to look like when we're all said and done. So that is our drive through option. And with that, I won't let it run right to the end. We'll hit pause there. And yeah,
Awesome.
I think that's it for me.
Yeah, and if you noticed a difference between the drive-through that I showed in the slides and Matt at the end, you have just gotten your first sneak preview of something that's coming in version 12, which is, yeah, we're basically cutting the terrain a little bit better for visual purposes. Anyways, more on that coming in the new year. So with that, everyone, thank you for hanging out with us for an extra 8 minutes. Really appreciate it. Loved having you here. We're going to tackle all those great questions from the chat afterwards through email. And if you're watching this video in the future off of YouTube, feel free to drop your questions below. We love answering them. Happy to address it. And with that, everyone, have an awesome rest of your day. New webinar calendar for 2025. First part, or first quarter, is coming out in the next day or two. So please, pay attention to that and have an awesome rest of your day. Hope to see you at another webinar in the future.
Thanks, everyone.